Okay, so we're going to do an example of solving by completing the square. And you'll notice right here on the side we have, in order to do that, we take b and divide it by 2 and square it. Remember that whatever is in parentheses as b divided by 2 is going to be our factor that's created. We have a couple steps in completing the square. And our first step that we're going to do is we're going to go ahead and we are going to move the constant. Okay, so I'm going to do that by adding 40 to both sides. Okay, and the second step, which we don't have to do here, but we're going to have to remove our leading coefficient. And you'll notice here our leading coefficient is going to be in front of the squared term. There is no leading coefficient here, so we don't have to worry about that. The third step is completing the square, and that was done in our previous videos, and we're going to see the process here. But the idea is, in order to solve, we're creating or manipulating a quadratic that maybe is not factorable that allows us to solve easily. This one is factorable, but I'm telling you to complete the square, so you have to go through that process. So the first thing that I'm going to do is I'm going to take 18x, 18 and divide it by 2 and square it. And we're going to take 40 and add that to both sides. We have to have balance, so what we add to one side, we have to add to the other. And now we know that 18 divided by 2 is the same as 9. So I'm going to put that 9 there. And the reason I'm going to put this 9 here is that we know that we're going to get a perfect square. So we're going to write our factor as x plus 9 quantity squared. And the trick is, what I just said, is that whatever this factor is, or whatever this b divided by 2 is, becomes our factor. And on the other side we have 40 plus, and we know that 9 squared is 81. 40 plus 81 is 121. So now I'm going to do a little bit of a side work here, and I'll just draw a line to divide it. If we had x plus 9 is equal to 121, we'd easily just subtract 9 from both sides and solve. Okay? So think about what we're doing here on the left side of this line that I just drew. We have the same exact thing, except the only thing that's in our way is a square. So how do we get rid of the square? Well, we take a square root. So I'm going to go ahead and take the square root of both sides. And when we do that, we have plus or minus in front, and the square root of 121 is 11. So the fourth step is to solve by a square root. Okay? And we have our two equations. We have the one where it's equal to a positive 11, or the one where it's equal to a negative 11. And it gives us the same answers as if we were factoring. We subtract 9 from both sides on this one, we get x is equal to 2, or subtract 9, we get x is equal to negative 20. And so these are our solutions we solved by completing the square. And now, just to look at a graph, just to reiterate some of the concepts that we've talked about, we have a negative 20 over here, and we have a 2 over here, and we have a parabola that would open up based on the function being positive, the leading coefficient being positive. And notice we're finding the same thing. We found the x-intercepts. So these guys are x-intercepts, zeros, or sometimes we call them roots. For what we do, it's pretty synonymous, but all these guys are just telling you to find the solution, set it equal to 0 and solve. And this is how we solve by completing the square. Completing the square is the tool that we use to solve, just like factoring is the tool that we use to solve.